This is a complete guide to HVAKR. We're going to focus on a commercial application and get into all the advanced features you might need for your project. If you're looking for a more basic tutorial, you can check out this video where I cover HVAKR for residential applications, but in this one, we're going to cover everything. So let's sign in and get started. Let's start with HVAKR's project library and the general layout. So when you sign in, it'll take you to your project library. This is where you would create projects. Once those projects are created, they live here. You can add folders and organize your projects as desired. And with each project, you'll also see a few examples. You can pin projects, you can archive projects, you can convert a project to a template, which we'll touch more on in a little bit. And then also, you can duplicate projects. Besides projects, you'll also find some tools that HVAKR has created here. So there's a site chart, this is interactive, and there's a ductilator. Down here in settings, this is where you can change some of your personal settings or your organization's settings. So here's my profile. I can change my default units here as well as my theme. This is my organization. I can add a logo. And this is seat management. So if you are an owner or an admin for your organization, you can allocate seats here. All right, let's get into a project. First thing I'll do is name my project and provide the product address. I would encourage you to start from a template. This is going to pre-populate a lot of your basis of design and save you the trouble of creating your profile from scratch. If you don't start from a template, there are also ways to import data very quickly into your basis of design, which I'll show you in a moment. For this project, I'm going to start with a commercial office building template. This will take me to my profile general tab. Now, to touch on some of the layout here, on the left, this is your navigation bar. And this is where you can go step by step through the process or jump around to various steps. Down here, you'll be able to print reports. And then these are my project settings. This is where I can switch my units and see who I'm sharing this project with. I can invite people to my project or even convert the project to a template. Up here, you'll see a few other buttons. This is my project chat. I can add notes for myself or for my team, so anyone on the project can go in here and communicate within the project. I can share this project from this button as well. Here I can add HVAKR's engineering or support teams if I need any support. This help button will give you links to our tutorials, our calendar so you can schedule a one-on-one meeting, and our support email. Okay, let's get into the design. This general tab is primarily for your team's documentation. It will show you the name, the address, you can insert a project number, and then everything down here is for your team to communicate the contacts, deadlines, codes, any other special constraints for this project. These do not affect your calculations. This is purely documentation for your team. Now, all of these first few steps, you will be able to export as a basis of design report. So anything you input here will appear on that report. In the next tab, I have weather. HVAKR will find the 5 nearest weather stations to your project and pre-select the nearest one. That's this one here. It's going to show me all my ASHRAE climactic data for that location. And if I scroll down here, I can adjust the design percentages or even hard override what these outdoor conditions are. Quick pro tip, this is where you would go to determine your dehumidification day loads. You can start with your peak heating and cooling loads, view that report, and then come back here, input your dehumidification conditions, and check the report again to compare. In the building tab, these first few inputs are just for documentation. They do not affect your calcs. With this building type input, you specify the general construction of your building, and that is going to determine the overall thermal mass of your building. This is also the first time you'll see this library book. If you select this, this will describe what the input is in layman's terms, as well as provide some references. You'll see this throughout the profile step. Going into wall types, you'll see that this table is already built out for me. That's because I started from a commercial template. Based on my project location, HVAKR found the climate zone that my project is in, and because it's commercial, populated my wall types, window types, roof, and slab with ASHRAE 90.1 minimums for non-residential climate zone 4 construction. So if I'm going off of limited information, I can start with a baseline here. If you want to customize these values, you can either override them here or just create a new wall type from scratch. This new wall type I'm creating is going to be for an interior wall next to an unconditioned space. And for that, I'm going to use the advanced settings. If you select this, you'll see a few more columns here. I'm still going to define my wall data and input a U value for this wall. For an interior wall next to an unconditioned space or for a below grade wall, you can select these check boxes and then specify what the temperature is on the other side of that wall. This is going to override the normal SOL air temperature used when determining your exterior wall load and use your inputs instead. So I'm going to specify 90 degrees for my summer and 40 degrees for my winter on the other side of this wall. Similar adjustments can be made to roof types and slab types. So if I have a roof with an unconditioned attic space above it, I can use the advanced settings to set up the same overrides for that. Or if I have a floor with an unconditioned space below it, say an underground parking garage, I can use these advanced settings, override the temperatures, and specify a U value for that floor. Lastly, aside from starting from a template or inputting your envelope types manually, you can import from other templates or other projects. So with that import button, I can choose from HVAKR templates, which includes all of ASHRAE's 90.1 envelope minimums. I can choose from my own personal templates. So if you save a project as a template, those data tables in your profile step can be imported to other projects very easily. I can also just find another active project that I'm working on and bring in the same values from that project into this one using active projects. All right, let's move on to space criteria. Here is where I'll define all my different space types for the project. These are not every individual space. You can think of it as creating templates for the various spaces that you're going to see. This was pre-populated when I created my project from an office building template. I can now go in and adjust these values as needed. I can also create new space types from scratch. However, instead of creating space types from scratch, I encourage people to go to import and find their space type in these ASHRAE building categories. So for this particular project, I know I need a few more space types that aren't already included, like corridors and conference rooms. As I scroll down, I'll find other exhausted spaces. This is where I'm going to grab a janitor closet and my restrooms. Then I will scroll down and hit import, and I'll see those spaces added to my project. Let's go through some of the parameters here. This covers your basic indoor set points. Summer set point, winter set point, what my range is, and what my desired relative humidity is in those spaces. The ventilation requirements cover my outdoor air rates required for each space type. You can see these are already built out based on ASHRAE 62.1 requirements, but you have full control and can adjust these if desired. There are also some advanced settings for ventilation, and these are crucial for healthcare work or lab work. With this selected, you'll see a few more columns where I could specify ventilation as an air change rate and even specify a minimum supply rate for that space type. If you were to import ASHRAE 170 space types from these tables, you would see that those advanced ventilation rates are already populated for you. Going further, I can set up global infiltration rates for my various space types here. This is also something I can override on an individual space basis in a few steps. In this table, I set up what my required exhaust rates for various space types. One thing to note here, if your space has a CFM per unit exhaust rate, like the restrooms, then when we create that space, we will have to specify how many units are in that space. For restrooms, it's going to be toilets. But for shower rooms, it may be shower heads, and you could even use this input to capture number of ranges in a kitchen and specify kitchen exhaust using the CFM per unit rate. Down here, I have interior loads. This captures my default people density, people loads, lighting load, and equipment load, or plug load. Here, I can set up schedules for my space types, and were I to customize these schedules, this is going to determine what percentage of my people, lighting, and equipment load that space is seeing at a given time. Lastly, we have sound criteria. This is optional and does not affect your calculations in any way, but could be nice for documentation when you go to print your basis of design report. Moving on to system criteria, I can input a system description that I want to see on that report, but more importantly, this is where I set up my duct types for my project. So at the end of this demonstration, we're going to do a duct design, and to prepare for that, I'm going to set up the various duct types that I might need for that design. I have full control over what these ducts are called and what the sizing parameters are for those ducts, so I can organize these in any way I want. For low pressure supply, I'm going to put in some basic values and also provide a max height. Now, max height obviously limits the height of your duct, but it also tells the program when to switch from a round duct to a rectangular duct and start getting wider. I'm going to use 14 for this. Liner thickness accounts for interior insulation in your ductwork and will calculate the size of ductwork required, including that insulation, to get the necessary free area for these sizing parameters. This register table is a beta feature. To take advantage of that feature, here you would provide the default diffuser type for each of these spaces and specify what the maximum flow rate per diffuser is going to be. a maximum velocity, and maximum noise criteria. With these inputs, we'll be able to quickly and automatically place the correct quantity of diffusers in a space in a general layout. Okay, with that, we've got our entire profile set up, and we can move to Sheet Library and import our drawings. In Sheet Library, you're going to follow this upload dialog to import a PDF of your floor plans. Once you begin uploading, it's going to split up all the different pages in your PDF into separate sheets. And from there, you can select which sheets you actually want to bring into your project. The bigger the PDF, the longer it takes to process. So if you want to speed things up, consider shortening the PDF before uploading. Okay, with these in, I'm going to select the pages I want to use as a backdrop for my design. And before I bring this onto my canvas, I'm going to specify which level this sheet belongs on, what the scale is, and what my default slab to slab and ceiling heights are for that level. A quick note on sheet number: it is important to provide a unique sheet number for each page you want to import. HVAKR uses sheet numbers to recognize revisions, so if I were to upload an updated set a couple weeks from now, I can provide the same sheet number for that sheet, and it will recognize it as a revision and slip sheet it automatically. Another note, for this particular project, I have 2 sheets per level. It's broken up into 2 halves. And so in this case, I'm going to be bringing 2 sheets in for each level. With that information provided, I'm going to grab the pages I need and bring them onto my canvas. Import. Now when I go to my sheet layout, I'm going to see those pages here. This is my canvas where I'll be doing the majority of my work moving forward, and I can navigate up and down levels like so. Going back to level 1, you'll see that it added 2 sheets onto level 1, and now I'm going to crop these and merge them together so I'm looking at one overall level. Right-click your sheet to crop and move these borders into place as desired. Then I can drag my sheet into place and lock. Now, I want to make sure my sheets on level 1 are aligned with level 2 and level 3. To do that, I'm going to use this marker right here and place it at an intersection that is shared across all levels. Now when I go up to level 2, I can make sure that this sheet is placed at that same intersection. And I'll do the same thing as before. Let's do the same on level 3. The last thing I'm going to check before I move forward is plan north the same as true north? If plan north is offset from true north, I can make that adjustment here. This is going to correct the orientation of my building. So if I were offset by 90 degrees, I could account for that here. With this set up, let's go ahead and get into spaces. In spaces, this is where I take off all my spaces and define my space types. There are a couple workflows here. The manual workflow is to create a space and use either the polygon tool or the rectangle tool to manually take off each space. You can do that like so. Once these spaces are created, I can select the space and then define what my space type is. Office. That's going to bring in all of my default office space calculated values. Number of people is based on that ASHRAE people density. My ventilation is based on those values. Infiltration is based on what I set up there. I can override these as needed. So if you have a furniture plan, you can go to custom and you can just hard input the number of seats in that space. And then down here, I can account for any miscellaneous load. So in a server room, I might input my miscellaneous cooling load in watts. Or in a kitchen, I might add miscellaneous latent load. And miscellaneous heating load might be applications like grocery store, where you've got a separate cooling system that's actually adding heating load to the space. To speed up this process, if you have a bunch of identical spaces, you can copy your inputs for one space and paste them onto another space, and that's going to build that out exactly how you did the previous space. So when I'm doing the manual method, I like to do each space type as a group and then move on to other space types. In this case, I might do all my offices, paste that data throughout, and then move on to my conference rooms, then my restrooms, then my corridors, and so on. Now, this was the manual workflow. With HVAKR's AI automation, I can let AI do this entire takeoff for me, as well as suggest space types with a click. So let's check that out. I'm going to press this button and run the automation for level 1, and it will suggest my spaces for me. So here are the results. It went through and took off all my spaces. It read the space name here on the floor plan, picked up that name and number, and also suggested a space type based on that name. So now I just have to review the results, pick up any spaces that were left out, adjust geometries as needed, and confirm my space assignments. Large open areas that encapsulate other spaces are going to be left out. That's up to you to decide how you want to divide that space. If you'd like to make changes to a space, you can right-click and you'll see some options here. I can edit this space, copy it entirely, rotate, flip, or delete. I'm going to delete this stairwell because it's unconditioned and not part of my plan. Over here in the lobby, I may edit this. I can now adjust the geometries of this space. By holding down the Shift key, you can delete existing nodes, or you can add new nodes, which allows you to make detailed adjustments to your space geometries. When adjusting these nodes, HVAKR is going to automatically snap to right angles, but if you hold Control, you can remove that snapping feature and be really specific with your placement. Next, I'm going to create spaces for any areas that were missed, like this conference room with a thin glass wall. Now, when I go to define this space, I can choose from these space types here, or I can utilize this button, which is going to search for that space name and find a space type that's associated with it. So if your space name is descriptive enough, it can search ASHRAE's data tables and find a space type for you. Next, I'm going to divide up this open area, and as I do that, I'm going to consider my zoning. So zoning is going to be in a couple steps, but it's important to note that you cannot split a single space up into multiple zones. A large area is going to be on multiple thermal zones. You will have to create your spaces according to how you want to zone that area, which is what I have here. And lastly, to finalize the spaces on this level, I'm going to scroll through my list of spaces here and look for any one that has a red dot next to it. That indicates that the space type was not found, and I'll have to input that manually. While I'm on this restroom here, let me point out, when using a space type that has a CFM per unit exhaust rate, you are going to see an additional input here called number of exhaust units. That's where you would input the number of toilets for a restroom or shower heads for a shower room to calculate the required amount of exhaust. Okay, with this level good to go, I would repeat that process for each level in my project. One additional tip, if you have levels that are identical, you can grab all of the spaces on a level and copy them as a group. Then you can go up to the level you'd like to place them and hit paste. From there, you could grab them all as a group and drag them into the appropriate location. All right, that wraps up spaces and defining the interior of my project. Now let's go to envelope and define the exterior. All right, let's get into defining the envelope for your project. There's a couple workflows for this too. I'll show you the manual method first. Starting with walls, we need to define the exterior walls for this project. So right now we have all the line segments from the spaces that we created, and we need to define which of these is an exterior wall and what wall type. To do that, you'll hit Assign Wall, select the wall type, enter, and then select the line segments that represent that exterior wall. You can click out or hit enter again, and that will create the wall. To do this quickly, you can group select walls and filter out interior walls. That looks like this. Assign a wall, make sure that this is checked right here. Limit wall assignment to exterior. That's going to ignore all of the interior walls on your project. I'll select the entire group, and it's going to capture mostly the exterior. If you have line segments next to areas that are not spaces, it will capture those too, so you'll have to be sure to check and remove any walls that aren't applicable. You can remove walls as groups by group selecting them, hitting this to edit them as a group, and then deleting them this way. This is also how you can change properties for a group of walls. I can select these walls, edit using this pencil button, and then change my wall type here. If you're using more than one wall type, you'll want to right-click and change the color of your wall type so it's easier to differentiate. Now, in this instance, I want to assign an unconditioned partition to these walls here by the stairwell. If you recall at the beginning of the project, I set up a wall type called unconditioned partition. So I'm going to use this wall type for these inside stairwell walls and hit enter. This is going to be my unconditioned partition wall type. Now you'll notice when I selected this line segment here, it took the entire length of that line segment, giving me a wall area that's too big. When this happens, to correct that, you'll need to go back to your spaces. You can edit that space, and you want to separate this line segment by adding a node. Hold shift and select where that wall ends, and then hit enter to save your changes. Now when I go back to my envelope, that line segment will be split up into two areas, and I can delete the portion that I don't need. Once you've defined your walls, we're going to add windows. To create a new window, click this button here, define your window dimensions, select a window type, specify shading if needed. This is going to give you external shading where you can specify your top overhang depth, your top overhang offset, your side overhang depth, and your side overhang offsets. When you've created your window, you can now go to your walls and place that window on your walls. If you need to make adjustments, you can select the window, change the window type from here, or change the dimensions. You can also copy that window's properties, select other windows, and paste those properties to another window. One thing that I like to do when creating windows is if I have an elevation drawing for the project, I will actually bring that onto my plans. I'll make sure that the drawing is to scale, and then I'll take that elevation drawing and move it off to the side. That way, when I'm doing my window takeoffs, I can actually go over here to view a window schedule if I have it and speed up this process rather than going back and forth. But also, if you don't have a window schedule and all you have is an elevation drawing, you can go to spaces and you can actually use the space creation tool to take off windows on an elevation drawing. If you've got the scale set, you can take off a window like this and use the dimensions laid out when you're creating a space to do that takeoff. That's windows. Once you've done wall and window, you can move over to roof and skylights in this next tab here. To assign a roof, I'm going to go to my spaces that have a roof above it, which in my case is everything on level 3, and I'm going to assign my roof. I'll choose the roof type, specify a pitch if applicable and the direction of the pitch, and then I will select the spaces that have a roof. In my case, it's all of these. That assigns a roof to those spaces. For skylights, it's the same interface as windows. I can set dimensions for a skylight, the skylight properties, and then I can place them on my roof like so. Next is slab. I'm going to go down to my bottommost level, which is slab on grade, and assign a slab to that level. So that's walls, windows, roof, skylights, and slab. There is another workflow to defining this envelope that could speed things up significantly. I'm going to remove these properties and show you that next. To do this quickly, I'm going to use this automation here. I'll define my envelope for all levels, specify my wall type, roof type, and slab type. And this is going to take off my exterior, ignoring the interior. This will take all the spaces on the utmost level and assign a roof. And this is going to take all the spaces on the bottommost level and assign a slab. For windows, with this feature, I can assign windows as a percentage of wall area. So if I don't have window dimensions and don't know the placement for the windows yet, I can just choose a percentage, and that's going to add that amount of glazing to my walls. So this is great if it's early on and you just need a quick calculation. So with this run, it assigned 298 walls, 73 spaces with the roof, 73 with the slab. And now if I need to assign different wall types to portions of this building, I can do it like so. I can also use this assign as percentage of wall area function for just a select number of walls like this. And then to delete a window, I can select and delete. With my envelope defined, I can go to envelope preview and see what this looks like in 3D. And this is a great way to gut check your work and make sure all your geometries look true to your building. You can also take a snapshot of this and download that. Okay, with all my interior and all my exterior defined, I can actually jump back to my spaces here. And if I want to see a preview of the loads for any given space, I can select that space, scroll down, and preview my cooling loads, which will show me the profile for my design day, peaks in August. I can also see a breakdown of my loads here. Okay, next is zoning. To create a zone, click Create Zone. You can then name your zone, select a color, and assign spaces to that zone. Click Out or hit Enter to lock in that zone. I have a partial zone map here. I'm going to demonstrate a few different system types using these zones. So to create a system, you'll, just like zoning, create a system, and then you're going to assign your zones to that system. First, I'll create a VRF system using these zones here. Then I'm going to demonstrate a package unit RTU single zone system using this zone here. And I'll demonstrate a VAV type system using these zones here. Now, with these spaces assigned to zones and these zones assigned to systems, I'm going to configure what these systems look like. In loads, configuration, my next step. Once you've done your zoning, you're going to see a line diagram like this. This represents the air side processes in your system. And you're not going to be selecting from a drop-down of different system types. You're going to be defining those processes yourselves. It's going to be done schematically by turning on different components in your central and your terminal units. Central units represent your system level equipment, any equipment that would be supplying air to your terminal units, which represent your zone level equipment. So for this air handler serving VAVs, it doesn't matter what I call it. It's all about defining what the air is doing. So I'm going to set up an air handler by turning on outside air, return air, a cooling component, and I'm going to leave my heating component off. I'll do VAVs with reheat. Although if I wanted a preheat coil, I could turn that on. And then with these different things selected, you're going to see some inputs for each one. So outside air, it's asking how much. I can specify sum of spaces, a percentage of my supply, or just a custom CFM. I'm going to do sum of spaces. So outside air is coming in at the required rate. The return air is coming back and mixing, and then it's hitting a cooling coil. For the cooling coil, I can specify different coil types. If I choose a water coil, I can also input the water delta T. That's going to give me a GPM. Direct expansion will specify direct expansion in your report, but the important thing here is to specify the air leaving that coil. What temperature is it? So I want 55-degree air cooling my spaces, and so I'll input 55. Down below, I have other miscellaneous inputs. This is where I can add fan heat gain for my system, other inefficiencies, which represents more or less a safety factor. I can account for supply, duct heat gain or loss, leakage, which I can also do on my return side. I can also add diversity to the system by putting in a percent here. So if I put 90% occupant diversity, it's going to reduce my people load to 90% of the total sum of spaces. Okay, now this is telling me in heating mode, I have a mixed air state that's passing through and going to my zones. In cooling mode, I have a mixed air state that's hitting this coil. It's being cooled to 55, and then it's going to my terminal units. So let's configure those terminal units. Here, I've got air coming from the central unit, and I'm going to turn on my heating coil. Now from here, I'll specify 90-degree air heating, and my coil type can be heating hot water with, say, 15-degree delta T. So that sets up my typical VAV system. Again, if I were to add a preheat coil to my central unit, I could specify preheat to, say, 50 degrees, and now the load on my heating coil for my terminal unit is going to be reduced. Okay, let's go over a single zone package unit. So here, it's a 1-for-1. This is going to be an RTU serving a single zone. So I'll configure my central unit as a package unit, just like the air handler. It's going to have the heating and the cooling like before. Outside air, sum of spaces. I want 55-degree cooling, 90-degree heating. And now for the terminal unit, I'm going to leave this blank. This is now just a piece of ductwork. So this is the zone. It shows there's a box here, but I'm indicating that there is no change in air going through this process. Lastly, let's set up a VRF type system. In this case, rather than having my return air at my central unit, I'm going to configure my terminal units with return air. And now the return air is coming back from the zones. It's going to be mixing with whatever is supplied from my central unit. And then the cooling and the heating is going to be done here at the zone level equipment. So this is essentially a fan coil unit. I still need to specify how much outside air is coming into each zone. And then I'll specify the discharge air temperatures for my fan coil unit. For the central unit in this system, if I don't want any outside air being supplied to these fan coils, say zero ventilation for whatever reason, then I can just leave this blank, but I'm going to be sure to configure these zones to have 0 outside air. But that's not what I want to do. So here, I'm going to specify how much ventilation is being given to those units and if it's going to be conditioned before it goes to my fan coil units. So I could set up an outside air DOAS system where this is a dedicated outdoor air unit with cooling and heating, and I'm going to temper the outside air before it reaches my fan coils. So I would specify the temperature that I'd like to temper the air to by indicating, say, 72 for cooling and 68 for heating. And that's going to essentially negate all of the ventilation load on the coils at the zone level equipment. Here I need to specify my outside air as sum of spaces. Now, if this was not a DOAS unit and it was just forced ventilation, I would simply turn these components off. Now I have unconditioned outside air being supplied to my zones. Lastly, I could configure this as an ERV or as a combination ERV with cooling and heating. But let's focus on the ERV portion. So when I turn on the ERV component, it's now going to take however much exhaust air I have present in this system, and that's what's going to run through this ERV process, my energy recovery wheel. The outside air will run through the other side, and once that ERV process is complete, I'll have a tempered air state that's going to be supplied to my zones. This is dependent on having exhaust in your system, and I'll show you how to check that in one step. Before I do that, with ERV, you're also going to have an effectiveness. You'll have to specify what percent effective that ERV is. Okay, exhaust for the ERV. So this is going to automatically calculate how much exhaust is in your system, and that's going to be determined by how you defined your spaces and whether those spaces have any required exhaust. But a quick way to check that is in our next step, air balancing. So loads, air balancing, spaces. Now I'm back on my spaces, and this time I can view all of the design CFMs for these spaces. I can also look at my zones here and select a zone and see those design CFMs. This is going to show me the calculated totals and what the design supply is based on these totals. This is where you can see whether it's your load that's driving your supply or if it's your ventilation. Now, for this VRF system, where I specified an ERV, I'm going to look at the totals there, and that's where I'll find what my total exhaust air is in the system. And in this case, I have none. My exhaust for this building is here in the restrooms, so those would have to be on this system in order to capture the exhaust that's present there. But if I wanted to manually add exhaust, I could go back to air balancing spaces and specify which spaces I'm going to add exhaust for the sake of the ERV. So I can go in here, and any of these values I can manually override. So this is telling me what the theoreticals are, what the design supply is based on the load calcs or potentially ventilation if that's what's driving it. But I can make an engineering judgment and I can override these values. This is really important if you need to balance your system, especially if it's a hospital or a lab. This is where you can really fine tune the air balancing for your entire system. You can specify supply, return, but also transfer in and out of spaces. That way you can be sure your airflow is actually going to the correct zone or system and being returned to the correct unit. You would go through and specify that. So in my case, previously I had 0 exhaust in the system. I can go here and I can add 200 CFM of exhaust. I can make sure that my return is set to 0 because now everything being supplied there is being exhausted. And now when I go back to systems, I'll see that in this VRF system, I now have 200 CFM of exhaust. Another place to see this is our load summary. So this takes us to our report for our loads. These are all the values you'd expect to see in your load calculation. Over here is how we navigate between our overall project. So this is telling me for the entire building, every space, what is the coincident block load for that project. And in my case, it's a little over 83 tons. I'll see a breakdown of all the space sensible components, internal, external loads. I'll also see some additional loads that would be applied to the system, like any plenum loads, latent loads, ventilation loads. And as I go down, I can see some checksums as well. So this is a handy one. It tells me what my square foot per ton is. I can check CFM per square foot and other information there. As I scroll down, I'm going to see my heating load. Same breakdown, but now for the heating, and I can see checksums for that as well. So in this project, I did not define all of my systems and all my spaces, just a select few, which is why you'll see unassigned zones and unassigned spaces. These are all the spaces that I have not zoned yet. I'm going to ignore those. I'll stick with the systems that I did define. So this air handler, looking at the air handler, as I scroll down, I'm going to see all my theoretical loads here. So for this system, I have 4 tons of cooling, which is just a raw calculation of all the load components in this system added up at the overall peak of that system, aka coincident load for the system. This is not a sum of space peaks. This is the peak of the system. As I scroll down, I'm going to see my cooling load. So this is the load on the coil per my configuration and design CFMs. So if I were to make changes in the air balancing step and adjust my supply CFMs and my return CFMs, this is actually going to factor that in. This is based on my design airflows and my design temperatures. It's also based on how I configured this air handler. So as a reminder, this air handler was configured like so. I have outside air coming in, mixing with my return air. I've got cooling going down to 55, and then I have a heating coil. This is tempering it to 50 before it goes to my VAVs with reheat. So when I'm looking at my central cooling data, I can see the state of my outdoor air, how much. I can see the state of my return air, how much, and this is giving me my mixed air state. So that's the psychrometric calculation for mixing for my outside air and return. And then I'm asking for 55-degree leaving. This is my supply. A change in enthalpy from this state to this state at this rate is going to give you 3.06 tons of cooling on that coil. On the heating side, I can see that I have this air in the winter. It's going to mix with my return air. This is the mixed air state, and I'm trying to up it to 50, and this is the load on that heating coil. Now, looking at my VRF system, here I'm going to see this exhaust air category and the amount. So there's that 200 CFM that we added to the system. There's 330 CFM of outside air. This TA is tempered air. That's the air leaving the ERV. There's no return air. So that's also the air that is leaving this central unit, which is configured like this. So the only process I have in this unit is in ERV. Now, to show you this for the zones, let's look at that VRF system again, where right here, the central unit, I have 87-degree dry bulb in cooling, leaving the ERV and going to my fan coil units. If I now select on one of these zones, not only will I see a peak for that zone, but here are the psychrometrics for that coil load. So here's that 87.3-degree air entering my fan coil unit. It's going to mix with the return air coming back from the zone, giving me this mixed air state. I'm asking for 55-degree air leaving, and then this is the load in order to accomplish that. So this is how to read the terminal cooling data, the central cooling data, and also compare it to your total theoretical load here. In this case, you'll see my theoretical load for this zone, I have a good amount of ventilation, but because of my ERV, that's actually been reduced. So I can see that without an ERV, I would expect something closer to 0.89 tons on that coil. But with a portion of that ventilation load being handled at the central unit, then I'm actually looking at 0.61 on that coil. Taking another quick look at air balancing. Now we have all of these airflows associated with these spaces. And this is a prerequisite to our dry side design. And if you're looking to do an HVAC duct design very quickly, this is the way to do it. I've got all these airflows associated here so that when I go to dry side design, I can quickly place diffusers. It will pick up how much airflow it needs, and we can start drawing our ductwork. Let's go over my workflow for dry side design, and I'll do a couple of those systems here. So first, I have some buttons up here to aid in my design. The first one I'll point out is this filter. I can turn on different views from this filter if I want to see my individual spaces and their CFMs, or check my zones again, or look at my systems. The workflow I like is to show my spaces, go to my registers here, and I'm going to start doing my diffuser layout. So starting with supply, I can add a diffuser here. And if I go up to my filter and turn on annotations, I can see this diffuser tag as I'm placing it. 200 CFM required, it gives me 200. 150 CFM required, you get the idea. Now, if I go to a large open space that requires multiple diffusers, I can place multiple, and it's going to split up that CFM between the two. Before I place diffusers, I can also adjust the dimensions of this diffuser. I can adjust the assumed throw area, and I can also adjust the tag here. So if I wanted a custom size diffuser, or say I wanted to represent a linear diffuser, I could set up something like this. This is going to represent essentially a linear slot diffuser. This is a very flexible tool. It recognizes that this is a supply outlet. And then from there, you can adjust the dimensions and the tag to make this represent whatever you want. Next, I'm going to show you this auto diffuser placement that I hinted at the beginning. When I select this button, it's going to ask me which spaces I'd like to auto place my diffusers on. I'll go ahead and select these spaces here. That's going to place these diffusers in a central location on those spaces. And from there, I can click and I can drag these diffusers around as needed. If you want to get an idea for your distribution, you can turn on the register throw and confirm the coverage looks good. Okay, once I've placed my supply, I'm going to go ahead and place my return. Now, for my fan coils and for my package unit, I'm going to have ducted return in each space. But let's say I wanted to do a plenum return for this system here. By default, when you place a return grill, say a sidewall grill, it's going to pick up however much return is required for the space in which you placed it. And in this case, I place it outside of the spaces that it's actually serving. So to account for that, when you select a register, you can change which spaces it is assigned to. So rather than the space that it is placed in, you can manually select which spaces it's responsible for. So for this VAV system here, that's on a plenum return, I'm going to select all these spaces. And now the amount of CFM required from this grill is going to reflect that. I can right click and I can rotate registers like this and move it into position as needed. With return grills placed, I'm going to show you exhaust. So just like with supply and return, if there is a required amount of exhaust in your space, you'll be able to see that here, and placing an exhaust grill is going to pick that up. With all my registers placed, I'm now going to move on to my terminal units. So you'll have some equipment available to you based on your zoning, and it will be tagged the same way that you tagged your zones. For my fan coils, I've tagged them AC1 through 6, and I like to turn on my zone view here as I go to locate my terminal units. So AC1 I can place, AC2, and so on. For my single zone package unit, I don't actually have any zone level equipment, so I can ignore this component here. I'll go over to my central unit and I will place that package unit where that belongs. This one I'll go ahead and place on the roof. In my case, I did not import any roof drawings, but I'll just go up to level 4 on the blank canvas and place that there. Once placed, I can adjust the size of this if I want to accurately represent the real estate that is taken up. And you'll see when you place equipment where the inlets and outlets are for that equipment. This is what we're going to connect our duct to. Before I get to ductwork though, let's go ahead and place a couple of VAVs for the VAV system. Going back to terminal units, I'll place my VAV1 here and VAV2 here. I can go in and I can rotate these as well. I'm also going to place my air handler up on the roof for my VAV system. Okay, with my equipment placed, let's do some duct layouts. The first thing I'm going to do is color code these so it's easier to track on the drawings. I like to make my outside air light blue. I like to make my medium pressure supply dark blue. My low pressure can be, it's up to you. This does not really matter, but it'll make it easy to identify. Now, when I select one of these ducts, that's going to be the duct that I am drawing with. With that, it will follow these sizing parameters. Reminder, you can edit those sizing parameters in your criteria under duct types. This is where those ducts came from. So going back here, I'm going to do my duct layout for this fan coil unit. I may first adjust my inlets and outlets. On this fan coil, I'm going to have a blue arrow in that represents ducted outside air. You can choose to use that or not. My blue arrow out is going to be my supply, and my red arrow in is going to be my return. So I'm going to draw my low pressure supply for this system here. By default, it's going to start you out with single line, and I like to stick with single line until I go to size my duct. Once my layout for a system is complete, I can switch to a double line view and then hit the size button. And it's going to size my ductwork based on how much CFM is in each segment and what my sizing parameters are for that duct type that I drew. You'll see here, this segment has 150 CFM in it, makes sense, and the calculated size was 8 inches based on those sizing parameters. I can override this size ductwork, and at that point, this essentially becomes a ductilator. So if I reduce this to a 6-inch duct, it's going to show me what my new calculated pressure drop is, and I can see right away that this is over my sizing parameters I have here. I can revert back to the calculated size by hitting that button there. If I wanted to switch to rectangular, I can do that. I can see what the new values are, and I can adjust my size here to see if I'm still within those parameters. Now let's do the same with return. And there we have it. That's one zone designed and sized. I'll go ahead now to my single zone package unit. In this case, I just have my central unit up on the roof. So I'm going to show you how to create risers, vertical duct, to go between levels. In this case, I'm going to have my low pressure supply coming off this, and then I'm going to use this button right here to add a low pressure riser. Once this riser is created, I'm going to right click on that, and I'm going to specify which levels it's going to. So this is going to be from level 4 down to level 1. And now as I go down, I'll see where that riser is going through the floor. If I were to adjust the location of this riser on level 1, I'll go back up and I'll see that adjustment happen. So let's go to level 1 and finish this layout here. I can come off here. Now when I hit size, it's going to size these ducts, it's going to size this riser, and I can follow it all the way up to my central unit. You can do the same on the return side. But let's move on to my air handler. Starting at the top, let's add a medium pressure supply coming off this air handler, and then a medium pressure riser, which is going to drop down to level 1. I'll follow this down. And maybe I want to adjust the placement of this. I may find that the shaft is actually going to be located somewhere over here, and this may prompt me to adjust the location of my air handler on the roof. Now, medium pressure coming off the shaft, I'll connect to my terminal units. Okay, medium pressure complete. Let's go back to single line view. Now I'm going to complete the low pressure. I'll adjust this to be off the side of the VAV plenum and design from there. To quickly remind myself, I'm going to turn my zones back on. VAV1 serves these diffusers over here. So let's go low pressure coming off to serve these diffusers. VAV2 serves these ones down here. Now with the supply side connected here, I can hit size, and it will size my low pressure, and it will size my medium pressure to their respective standards. Lastly, let's do the return drop for this system. Going back up to my air handler, I may have return coming off the side. I'm going to route that over to where my return riser is. Let's place that right here and specify level 1. From here, I'm going to connect my return to my return grill for this system and hit size. Another note, you can also override how much CFM is coming through each diffuser. So if you would like to make a change at this step in the process, you can select a diffuser and you can just manually enter how much CFM is going through that. Your sizing calculations will be adjusted when you hit resize. That said, if you are going to change CFMs, I recommend you do it on the air balancing step. Okay, 2 more systems I want to show you. Remember that ERV that we set up for our VRF system? That was this guy right here. Well, this is represented as my central unit VRF, and I could go back to my systems. I could change the naming of that to ERV so that my central equipment is tagged as ERV. Then when I go to my duct design, I can use this box to place an ERV in my plans. And here, I'll make this smaller. This blue supply outlet coming off the ERV represents the outside air being supplied to my fan coil units. So I'm going to route my outside air duct coming off of this ERV, and it's going to go serve this fan coil unit over here. I'm going to connect it to my blue inlet for this fan coil. And this recognizes that the amount of outside air required for this zone is the amount of CFM being supplied to this inlet. So I can see here when I click this duct segment, there's 70 CFM being supplied to this unit. And if I check my air balancing for AC1, I'll see 70 supply going in, and the outside air required is 61. So it's automatically rounding up to the nearest 10, but this 70 is based on the required outdoor air for this zone. This allows me to size the duct for my outside air when connected to my outside air inlets for my units. The last system I'll show you is this exhaust for the restrooms. So we don't actually have an exhaust fan piece of equipment here, but to represent the exhaust, I can still route my duct. I can add an exhaust riser, and I could take this all the way up to the roof. This might be on a central exhaust system. I can hit size, and then I can follow this all the way up to my roof and see my exhaust outlet here. And this will show me what my total CFM is for my exhaust. Okay, we've got our diffusers laid out. We've got all of our tags. We have our duct layout, sizing, equipment placement. One additional feature here is the pressure loss calculations. To access those, I'm going to hit this Find Critical Path button, and this will highlight the critical path for every system that I drew. It'll give me the supply critical path, the return critical path, any connected system. It will tell me the path of most resistance. So if I focus on my VAV system here, I'll see that coming from the central unit on the roof, my supply goes down, and my critical path takes me all the way to this last register here. If I want to isolate one of those, I can select that system here and see that this is the critical path for my supply. I can expand this and see a breakdown of all the different components going through my fittings, my straight duct, etc. This is telling me that the total comes out to 0.47 inches of external static pressure. These calculations are based on some theoretical values and general assumptions around fittings. When you drew your fittings, you were not specifying exact smack down numbers. It's this elbow with this many turning vanes. But when you draw that fitting, HVAKR recognizes what that looks like and utilizes some standard pressure loss factors. For this elbow here, you can see that it's using a factor of 0.3. If I can adjust this right here, if I want to override that, so to really fine tune my pressure loss calculations, I can go through to various fittings that may be unusual, and I can adjust what the pressure loss factors are there. So this Y is showing me a couple different paths and the data associated with that. From C to A, I have pressure loss factor of 0.211. C to B is 0.273. So I can adjust these, or if I want, I can forego this entire pressure loss calculation and just hard input the amount of pressure loss going through that fitting. That would be this input right here. In my system, there are also a couple areas I can add additional pressure loss. So for this VAV, I can select that, and then I can add additional pressure loss here. That might represent filters, dampers, any other equipment near that VAV or in that system that you'd like to pick up some additional loss for. You could do that here. You can also factor in additional pressure loss for your registers. So as you're placing registers, you can make that a global input, or for a specific register, you can go in and you can change what that pressure loss is. This might represent flux duct and a manual volume damper, maybe a fire smoke damper nearby. I can account for that here, and it's going to update my external static based on that. With this duct design done, if I want to export this view, I can do that here. This will give me a PDF of what I see on my screen. That includes whatever filters I have on. So I can export a single line view with no annotations, or full annotations, double line view, even critical path if I have that turned on. When you go to export, you can name that drawing, you can specify a page size, and then it is going to take that sheet and it will export a drawing that is to scale for that page size. This is what that looks like. Simple title block with your company name and timestamp, drawing name and project name. For another view of this system, you can go to Dry Side Design Preview, and this is going to give you a 3D view of the systems that you modeled. We can see my fan coil unit system here, my single zone package here, and my VAV system here. Following this, if you want to take off of your ductwork, you can go to Schedules, Duct, and this is going to give you a duct takeoff. This is a breakdown of your different duct types organized by size, and then the length of duct for each size and each duct type, as well as the number of fittings. You can download this as a spreadsheet if you need to do some duct estimating on top of this. Okay, that takes us through the entire process in the HVAKR, going from setting up that basis of design, doing your load calcs, getting your system configured, air balancing, duct design, pressure loss, takeoffs. Now let's get into some of the reports you can generate. So down here, you'll find reports, and you have a few options. When you go to generate a report, you can select 4 different types. There's the basis of design, which is going to give you all that information you filled out in the profile step, any general notes, your weather information, a map of your project, wall types, space types, system criteria. It's going to create a PDF 8.5 by 11, nice packet that becomes a basis of design. When you generate your heating and cooling loads PDF, this takes all that information from your load summary and also gives that in 8.5 by 11 format. Here's what that looks like. This table of contents is hyperlinked, so I can quickly navigate to my systems. You'll get a page for cooling and a page for heating. Additionally, you can generate that report as a CSV. That's going to give you 3 different spreadsheets. It'll give you a space table, zone table, and system table, and all of the loads data that you see in the app and in the PDF report, but in a CSV file. So from there, you can create schedules. I like to use the zone CSV report to create equipment schedules and get all the load data from my different zones. You can do the same with systems, or you can just export all of your spaces if you need to run some additional calculations from there. Lastly, we have the space, ventilation, and airflow CSV. And this is probably one of my favorites because this is what I use to create a ventilation schedule very quickly. This ventilation schedule is going to give me all of the data on airflow for my spaces. To quickly go through this, you'll see each of your spaces in a row, systems, zones, space type. This group here is going to show you all your ASHRAE 62.1 information, people and area rates, and what the required outdoor airflow is. Following that, we'll have any advanced info. So if you have an air change rate, you'll see that here. Your exhaust calcs will be outlined here. This portion here will show you any other calcs that might drive your supply CFM, like a minimum supply air required, what the cooling load determined supply is, and what the heating load determined supply is. And then finally, you're going to have a breakdown of your design supply, return, exhaust, transfer in and out, and ultimately your differential for each of your spaces. To create a ventilation schedule, I'll just remove the columns I don't need and reformat. All right, and that's it for our in-depth comprehensive guide to HVAKR. If you have any other questions, don't hesitate to reach out by sending us a support email or scheduling a call here.